This is a quick video on looking up information and data about compounds online, in particular using two tools. Those would be MarvinSketch and also the Japanese spectral database. So first of all, what you'll do in MarvinSketch is draw your structure, and then you'll use the File, Find Structure online menu. Once you find the structure online, you'll have access to physical constants like boiling points, melting point, densities, appearance, kinds of things that you need for doing your pre-labs for each experiment. You can also customize your menu to make it a little easier to do these things. Once you look up the information, then what you do is you record the CAS number, and I'll tell you what the CAS number is in just a second and where you can find it, and you take that number over to the Japanese spectral database where you can get more information like infrared spectra and NMR spectra as well. So this is MarvinSketch, and what we'll do is we'll quickly draw a compound. We will use an acetophenone derivative, and I'll place methyl groups on the structure, and then you can go into File and look for information in one of these three websites. Before we do that, I wanted to show you very quickly how you can modify your toolbars. So you go to Customize, Toolbars, and we did a personal toolbar in an earlier video. And what I'm going to do is I'm going to add Application, Find Structure in ChemSpider, Find Structure in Chemicalize, Find Structure in PubChem, and then I'll close that, and then you'll notice they've been added to the end of the toolbar down here. You'll see them up here. The toolbar is a little clumsy because it's so large. So what I'm going to do is I'm going to modify it, rename it, and just get rid of the find. I'll modify this one, and I'll modify this one. And hit OK, and hit OK. And now we can find structural information, physical constants, for example, in ChemSpider. It'll open up your browser, or Chemicalize and do an exact search, and PubChem, and also do a full structure search. Now, you'll notice in ChemSpider, this is the systematic name for the compound that's shown. It also gives you information like boiling point. Now, you'll notice this one, 275.78 at 760 millimeters of mercury. You'll notice this 112 at 8 millimeters. That means at reduced pressure, because if you remember, atmospheric pressure is around 760 millimeters of mercury. You want the 760 millimeter value for the boiling point and not the reduced pressure value. Now, I know where to find the CAS number in Chemicalize, and it's right there, so I'll copy that. And there's more information also in PubChem. This is the National Institutes of Health website for looking up structural information, compound information. And now I'm going to go to the Japanese spectral database. Comes up very quickly. It's a very common search, and I search it all the time, so that's why it pops up first in mine. Click on that first link. Click on the disclaimer. And this is the Japanese National Database for information about compounds. And now what I'll do is I will plug in the CAS number. The CAS registry number stands for the Chemical Abstract Services number, and they assign a unique number to every compound. So when I enter this number that I copied over from Chemicalize, this is the number specifically for that compound, and now I can search it and see what comes up. So you notice I get one compound here. It's the 2,5-dimethyl acetophenone. The primes mean it's on a substituent. The number's on a substituent. And now I can look up the proton NMR or the carbon-13 NMR. So let's quickly look up the proton NMR. Couple of bits of information. It tells you what all the proton peaks are in terms of, gives you a spectral view, and also gives you the ppm shift values, and then it assigns, for example, A, which is ortho to the carbonyl group, is shifted to 7.4, B is shifted to 7.1, and C, which is meta to the electron withdrawing group, is 7.0. It also shows the non-aromatic alkyl groups and gives their positions. And you'll notice it has an asterisk by these, and it indicates that those peaks are actually very close to each other. If you click on, so with that information, you should be able to find plenty of information about the compounds that you're using.